Okay, so hello everyone, welcome back to CodeSpide. When we run a Java program, have you ever thought about where our variables, objects, methods, and classes are stored? How does Java manage all this data in memory? And why do we sometimes get error like stack overflow error and out of memory error? So don't worry, in today's video we will understand Java memory management in the simplest way possible. By the end of this video you will understand the stack memory, the heap memory, the method area, and the complete execution flow of the memory. So let's get started. What is memory? What is memory management in Java? Whenever we run a Java program, the JVM, Java Virtual Machine, allocates memory to store different types of data. Think of JVM memory like a house in different rooms. Each room has a different purpose. The three main memory areas are stack memory, heap memory, method area. So let's understand them one by one. So first one is the stack memory. The stack memory is used to store local variable, methods call, method parameter. Whenever a method is called, JVM create a new block inside the stack called stack frame. Suppose if we take an example, that's public class test and public static void main, and here we write int a equals to 10 display method. So public static void main display method, inside display method we have another variable that is int b equals to 20. So when the program start, main enters the stack. Now main method call display method, a new stack frame is created inside the stack. So again display method and b equals to 20 is stored here. Before main method and a equals to 10 is already there. So after display finish, its memory is automatically removed. So lastly, inside stack there is only one stack frame, that's the main, and a equals to 10. So this follow the rule of LIFO concept. The process behind of stack is LIFO, last in first out. So just like a stack of books, the books placed last on top is removed first. This is the principle. So important point about stack memory, it store local variable, store method calls, very fast execution, automatically managed. Each thread gets its own stack. If we talk about the error like stack overflow, suppose a method keeps calling itself forever, like public static void show method, or you can say that's another method. The stack keep growing. Eventually there is no space left. Then Java throw java.lang.stack overflow error. Next, if we talk about heap memory, let's understand heap memory. Heap memory is the area where objects are stored. Whenever we use the keyword, the new keyword, Java creates an object inside heap memory. If we use the new keyword, if a uses of new keyword is arrived, then Java creates an object inside heap memory. Heap memory is responsible for creating and storing the object, used for storing the array, instance variable when it is triggered, when memory is actively allocated here, when the new keyword is used, scope shared among all execution threads simultaneously, capacity and speed, larger capacity than the stack but with slightly slower extent. Suppose if we take an example of heap memory, so there is example class student, string name, public class test, public static void main, student s1 equals to new student, s1.name equals to Anubhav. So here the object is stored in heap memory. The reference variable s1 is stored in stack memory. Memory view, if we talk about the stack, inside stack there is a s1 and inside heap there is a object, that's the student object, name equals to Anubhav. So this of it like this, s1 is just the address of the house. The actual house object exist in the heap memory. If we talk about the multiple objects, student s1 equals to new student, then another object creation, student s2 equals to new student, Java creates two different objects, object 1, another one is object 2, and stack store their reference s1 object 1 and s2 object 2. This is the main scenario between heap and stack memory. Then moving to the next topic, that's the garbage collection. Suppose student s1 equals to new student, we have the object creation. Then if the s1 assigned null value, so now no variable is pointing to the object, that's object become useless. Java garbage collector will remove it automatically. This process is called as garbage collection. This helps save memory. The cleaning process is automatically done by the garbage collector, and this process used for memory management or saves to memory. Here you may found an error, that's the out of memory error. If we continuously create objects while true new student, if we write here means we write repeatedly, we create object here, so heap memory eventually become full. When heap memory is full, then Java throw this type of exception, out of memory error exception. It belongs to the java.lang package. This is a complete scenario. If repeatedly we create object, then this type of error will occur. Then moving to the next memory units, which is called as method area. Now let's understand method area. Method area stores class information, static variable, static method, bytecode. Whenever JVM loads a class, its information is stored in method area. It's majorly working principle of method area to store the class information, static variable, static method, and bytecode. Suppose if we take an example, class student, static string, and another show method, then inside show method we want to print a message. So method area here store student class, college equals to ABC college, then show method, then bytecode. So this is the main principle. So the single source of truth is here. No matter how many objects are created in the heap memory, but only one copy of static data exists inside the method area. Only one copy of the static area exists inside the method area. All object reference this single central source dramatically save memory. So like if we create student 1, student 2, student 3, student 4, student 5, even if we create multiple objects, existence or the one copy of static data exists inside the method area. If we talk about why is static data stored here, why, what's the reason? Imagine if we write student s1 equals to new students, and again if we want to create student s2 equals to new student, again if we want to create student s3 equals to new student, even though there are three objects, Java creates only one copy of static variable, that's the college, because it is static. This save memory. So the complete example is here. Here the static variable string, the ABC, college equals to ABC, string name, then another class test equals to public static void main, student h1 equals to new student, s1.name equals to Anubhav. So where is everything stored? Here firstly method area inside student class stored and college equals to ABC. Then another in heap memory, it stored the student objects and name equals to Anubhav. Then inside stack memory, main method h1. So remember, local variable it's directly stored inside stack memory, the objects directly stored in the heap memory, and static data inside method area. This is the main scenario of the entire heap memory and stack memory. So here s1 means it's a reference variable. Here student means creates the local reference variable in stack memory, then loads the class blueprint into method area, then after creating of the reference variable, this object allocates the actual object in heap memory. This is the object which is directly stored inside s1. s1 is directly referred to the object. Then the complete differentiation of stack memory, heap memory, and method area is here. So primary contents is local variable, method call, object area, class metadata, it's thread specific, it's shared. It's a LIFO concept, garbage collector, JVM shutdown. Access speed is faster and it's slower Associated error means stack overflow error is triggered here. Repeatedly out of memory error you will see here, and out of memory error in metaspace also you will find here. So this is the complete differentiation between stack memory, heap memory, and method area. So if we talk about some interview question or important questions, so some questions are here. First one is where objects are stored. Where are objects and array stored? The answer is heap memory. Where do local variables and method parameter live? Stack memory. Where is static data and class bytecode loaded? Method area. Which specific memory zone is managed by the garbage collector? Heap memory. So master the architecture, master the JVM. If we master the architecture of the entire JVM, then you will definitely trigger, if we definitely crack any type of interview. So this is all for today. Stack memory store local variable and method calls. Heap memory store objects and array, and method area store class information and static memory. If you understand these three memory area, Java become much easier to learn and many interview questions become simple. If you found this video helpful, don't forget to like, share, and subscribe to our channel. So that's all for today. Thank you for watching and see you in the next video. Bye.